Okay, this is the final test review before your big test, which I know you all succeed very well on. All right, number 3, we want what are 2 more ways to name line AD. So here's line AD, and remember, you can name a line with any 2 points that lie on that line. We can name that line AB. We can name that line BD. We can name that line AD, or we already did AD. We can do DA. We can do A or BA. We can do any 2 points that lie on the line. Or if you don't want to use this symbol and you see a little lowercase italicized letter, you can call it line with the word line and then the lowercase italicized letter for N. Number 6, the intersection of 2 planes. Remember, two planes intersect in a line. So your answer should have the symbol for line over it. And here's plane QRB. So it's this whole plane. And TSR is over here, T to S to R. So this plane, and do you see where these 2 planes come together? QR. And remember, it's a line QR, or you can call it line RQ. Number 9, if XZ, so the entire length of this segment is 50, what are XY and YZ? So first we have to solve for A in order to figure out what the lengths of X, Y, and YZ are. Well, every time you have a segment, remember that the segment addition postulate, XY plus YZ equals the whole thing XZ. That is always true. And now we fill in what we have. XY is A plus YZ, which is A plus 8, equals XZ, which is 50. So we have 2A plus 8 equals 50. I'm going to subtract 8 from both sides. I'm going to come up here, and I get 2A equals 42. I divide by 2, and I get A equals 21. Okay, but don't just give me that as an answer. I didn't ask for A, I asked for XY and YZ. So XY represents A, and A is 21. So XY is equal to 21. YZ is represented by A plus 8, and A plus 8 would be 21 plus 8. So YZ is going to equal 29. And the check that you want to do, even if I didn't ask you for XZ or Y or XY or anything like that, is plug your variable in anyway and make sure that the segment addition postulate you had here is true. Does XY, which is 21, plus YZ, which is 29, does that equal what we said it equals, which is 50? Well, 9 and 1 is 0, carry the 1 is 50. So we know we did it right. Okay. Number 13 says use the diagram to the right, so we're using this picture right here. First, we need to notice that NQM is congruent to or equal to PQR. And that's notated by this arc on each of those angles. So we're told that MQR, M to Q to R, this whole thing here, is equal to 61. MQP, M to Q to P, is 25. And PQR is what we're looking for, PQR. Well, turns out these little red arcs right here, they're not helping us in this problem because we don't know if this MQP is congruent to this PQR. But what we do know is the angle addition postulate is true as well. The angle addition postulate says that this angle, MQP, plus this angle, PQR, is going to equal the entire angle, MQR. So we were told MQP, which is 25, plus PQR, which we don't know, equals MQR, M to Q to R, which is 61. So this just becomes a basic subtraction problem. I'm going to subtract 25 from both sides, and X equals what I get, 36. and then we check. Does 25 plus 36 equal 61? 36 and 25, 1, 61. So we're good. For 15 through 23, we're going to name a pair of each for the following. Pair of angles, obviously. Complementary angles. Remember, complementary, there's a C that we can draw a 9 down it, so that's 90. That tells us that complementary angles are 90 degrees. So what I'm going to look for is something that tells me that I have 90 degrees, and that's right there. Now, which pair of angles make up that 90 degrees? Well, I have this angle, and I have this angle, and they together make up 90 degrees. So it's DEC and angle CEB. Number 19, we're asked to find the value of x. Well, this is nice because very rarely are we only asked to find x. Usually we're asked to plug x back in to find a measure of an angle or a length of a segment or whatever. So this one's going to be pretty easy. But we need to know what our relationships are. Well, for number 19, we have a straight line, and you have 2 angles that make up that straight line. So when 2 angles make up a straight line, that's half a circle, they equal 180 degrees. It's called a linear pair. That's a pair of angles, 1 and then 2, that are adjacent, so they share this common side, and they make up a straight line. Their sum is 180 degrees. So exactly what I just said. Their sum, 3x plus 31 plus 2x minus 6 equals 180 degrees. We're going to combine our like terms. 3x and 2x is 5x, a positive 31, and a negative 6. That's just like saying 31 minus 6, which is still a positive 25, equals 180. Subtract 25 from both sides. So I get 155. Oops, 155 equals 5x. I'm going to divide by 5 on both sides, so I get x equals 31. Now, granted, it did just ask us for the value of x, but we are good students and we always check our work. So I'm going to plug x back into here, and I'm going to plug x back into here to make sure they do in fact equal 180. Well, 3x plus 31 is going to be 3 times 31 plus 31, which is going to be 93 plus 31, which is going to be 124. So that's this angle right here, 124. 2x minus 6, 2 times 31 minus 6 is going to be 62 minus 6. So it's going to be 52. Oops, not 52. Sorry, not 52. 56. So this angle right here is 56. And now we have to check. Does 124 plus 56 equal 180? And it does. So we're awesome. We did it right. Number 24, find the coordinates of the midpoint. So they are just straight up asking us for the midpoint of segment AB. Well, midpoint formula. We want to find the average of our x values, and we want to find the average of our y values, and we want to write them as a set of coordinates on a coordinate plane, x and y. So average of our x values would be negative 3 plus 3 divided by 2. Negative 3 plus 3 is 0 divided by 2, which is 0. So our x coordinate for our midpoint is 0. Then we want to do the average of our y values, 2 plus a negative 2 over 2, which is 0 over 2, which is 0. So that's our y coordinate, 0, 0. And now let's check to make sure if the answer makes sense. Well, let's look at our x values. We have negative 3 down here, negative positive 3 over here, sorry, because negative 3 and positive 3. And we just want to see, do you think 0 is in the middle? Well, negative 3, negative 2, negative 1, 0, 1, 2, 3. Well, it is in the middle because they're exactly the same distance from 0. Then check your y values. Here's 2, here's negative 2. Is 0 in the middle? Well, 2, negative 1, or 2, 1, 0, negative 1, negative 2. And there's exactly 1 in between each, so that's exactly in the middle. For number 25, it says that M is the midpoint of JK. We want to find K. Well, if JK is a segment and M is the midpoint, then we want to find K. K represents the other endpoint. Here's one endpoint, J, which is given to us, and we want to find the other endpoint. So that's EMO. So our endpoint, which was J, goes on top, negative 8, 4. Our midpoint goes in the middle, negative 1, 1. And we need to figure out how to get to the other endpoint. So how does a negative 8 become a negative 1? Well, we're going up on the number line, and we're going up by 7. So now we need to take our negative 1 and go up by 7 from negative 1. So negative 7 minus 1, or negative 1 plus 7, is a positive 6. And then how do we get to, for our y values, how do we get to from 4 to 1? Well, we're subtracting. 4 becomes 1 by subtracting 3. So 1 minus 3 gives us a negative 2. So our other endpoint is 6, negative 2. Number 28 says find AC. Well, what about AC? Well, remember, difference between this AC and this AC, without the segment bar, it's telling us to use the distance formula. The distance formula, you have to have it memorized. Start with a negative, and a plus in the middle. Then write the square root, and it's going to be x minus x squared, this is terrible, plus y minus y squared. But we need our coordinates for A and C. So A is over here at 0 on our x-axis, up 4. So A is 0, 4. And C is 1, 2, 3, 4, negative 4 on our y-axis, or x-axis, sorry, and then 1, 2, 3, 4, negative 4 on our y-axis. And now we just plug into the formula. So we have x minus x, 0 minus negative 4 becomes 0 plus 4. We're going to square it, plus y minus y, 4 minus y, negative 4. We're going to square it. Negative minus a negative is plus. 0 plus 4 squared is 4 squared. 4 plus 4 squared is 8 squared. 4 squared is 16. 4 times 4 is 16. 8 squared is 64. This gives us the square root of 6 and 1 is 7, plus 6 and 4 is 10, so square root of 80. And usually you're asked to round to the nearest tenths. So we're going to do 80 and we're going to square root it. On your calculators, you're going to do square root button first and then 80. So we get 8.9 round to the nearest tenths. This is less than 5, so it just stays as 8.9. Number 30 is an angle proof. We're given that angle 1 is congruent to angle 3. And here we see angle 1 is congruent to angle 3. So that's my given. And here's a word bank here. If you notice, there's only going to be 3 different reasons, except for the given, but I don't put that in the word bank because you know that one. 3 is congruent to 6. Well, that's why they give us a picture. 3 is congruent to 6. Well, why is 3 congruent to 6? Well, look at your picture. You have 2 non-adjacent angles, and they're across from each other. They share a common vertex. Those are called vertical angles. And vertical angles are congruent. So 3 is congruent to 6 by the vertical angles theorem. If you have vertical angles, which we do, 3 and 6, then they are congruent. Then we have that 1 is congruent to 6. Okay, well, in this line we have 1 is congruent to 3, 3 is congruent to 6, and then my 3's go away, and I'm left with 1 congruent to 6. Well, remember your transitive property. When the 2 middle terms are back to back, so here's our first line, here's our second line, and the two middle terms disappear, go away. We're left with the first and the third. First and the third. That's called the transitive property. Okay, next line says that angle 1 is congruent to angle 4. Well, I don't see an angle 1 or an angle 4 anywhere in these statements. So let me look back at my picture and see if that helps me. Oh, here it is again. Angle 1 is across from, not adjacent to, angle 4, and that is a set of vertical angles, and vertical angles are congruent. That's the vertical angles theorem. And then we have 6 is congruent to 4. Well, this line says 1 is congruent to 6 and 1 is congruent to 4. And then we have 6 is congruent to 4. So what we've done is we've replaced this 1 here with angle 6. And the reason we could do that is because we said angle 1 is congruent to angle 6. So we can replace this angle 1 here with angle 6. And that's called the substitution. And the only reason it's not transitive property is because if we took these from one line to the next, the two middle terms aren't the same. So technically it's not transitive unless the two middle terms are the same and then they drop out. Okay, that completes the test review.